So in this lecture we would study the mechanism of inserting a new node at some intermediate position. Intermediate position within a doubly linked list. Within a doubly linked list. So that means suppose this is the head pointer, and in this example we would assume that we already have a doubly linked list available to us. That means we have already created a doubly linked list. So this will point to the initial node, that is node number 1 of the doubly linked list, and this node is as per the template we used in the previous lectures. So there should be no confusion at all about this. Now this is the first node, and its back, this is the back pointer of the first node, this is the forward pointer of the first node. This back pointer points to null, this back pointer points to null, and this forward pointer points to another node. Okay, and suppose the data part is 5 and its data part is 10. This is the back pointer of node number 2, so this will point back to the previous node, that's node number 1, and this is the forward pointer of node number 2. This will point to the next node, that's node number 3, and this is the backward pointer of node number 3. This will point back to node number 2. Suppose the data part is 20, and since as in the last lectures we assumed that our doubly linked list consists of only 3 nodes, so the forward pointer of this node number 3 would point to null. That means it would indicate the end of the list. That means there is no node after this third node, right? Suppose for example this is node number 1, this is node number 2, and this is node number 3. If we are asked to insert a new node at this position, that is, we have to insert a new node at this position, which means after the second node and before the third node. Okay, so for that matter we will need to create a new node first, and you know that we will be able to create that node using malloc function. Okay, suppose this is the third node we have created, and its data part is for example 15. This is the back pointer, so it will point to null because initially we create this node. This is the single node we create using the malloc function, so this forward pointer will also point to null. And suppose its address is contained in a pointer called as PTR. So PTR points to this node. So what is the problem? The problem is we have to insert this node, this newly created node, at this position. That means after we perform this operation, this new node must become the node number, it will become node number 3, but after insertion. After insertion this node will become node number 3, and this will become it will change to node number 4. It will be the node number 4 then. So our region of interest is this. So let us call this region ROI. This is our region of interest. So we will have to pick this node and insert it here. Okay, but for that matter we will only be able to insert this node at this place once we reach this place. So we will have to traverse from this node to this node so that these links are available to us. This forward pointer of node number 2 and this backward pointer of node number 3, this becomes available to us so that we will make them point to this node, this newly created node. So we will do one thing. How will we achieve this? This is like, we will say we will declare a pointer of type head. So we will say struct, as was the name of the template in previous lectures, dbll star. Let us name that pointer which we will use for traversing from this position to this position. Let us call that as traverse. Okay, and let us initialize that to head. So with this statement what we are doing is we are declaring a pointer called as traverse which will point to the node, the address of which is contained in head, and you know that head contains the address of node number 1. So this means we create another pointer which we name as traverse. This is traverse and it also points to node number 1. Like head points to node number 1, this traverse will also point to node number 1. So now we will use this traverse pointer to traverse from this position to this position. How will we do that? See, we'll say now we have to traverse to this position. That means we have to traverse to position 2 so that this forward pointer of node number 2 becomes available to us. So we'll say we will declare an integer variable. Let us name that as index. Initialize that to 1. Okay, then we will say while index less than 2. While index is less than 2. So while index is less than 2, we will make this pointer point to the next node available. So at the moment this is pointing to node number 1, but we have to advance it by one node at each iteration. So we will say traverse equal to traverse FPTR. Then we will increment the index. We'll say index plus plus. So see what happens. At the first iteration, index is 1. So okay, index is 1. Now is 1 less than 2? Yes, it is. So once this condition is true, these statements will be executed. So traverse is actually pointing to node number 1, but after executing this statement, that's traverse is equal to traverse fptr. That means now in traverse we are assigning the traverse the address contained in traverse fptr. Now this is traverse fptr, this is fptr of node number 1. So this fptr contains the address of second. So what we are achieving with this statement is we are making this traverse point to node number 2. Now this traverse pointer advances one step, and now this is traverse after first iteration. This now points to this. So this link is now non-existent. Now this traverse points to this. Okay. So index becomes 2. Now this will move back to this while statement. It will check, is now index is 2. Is 2 less than 2? No. Now this condition becomes false. Once this condition becomes false, these statements will not be executed. So control will come out. Control will come out of this while loop. So once control comes out of the while loop, but before that we have made this traverse pointer advance one step, and now it points to node number 2. Once it points to node number 2, this forward pointer of node number 2 becomes available to us, and this contains the address of node number 3. So now we have reached in our region of interest. We have reached in our region of interest and ready to manipulate the this region. Now now we can easily do one thing. We can easily this FPTR of this second node, that is traverse FPTR, this points node number 3. But what's the problem? We have to make this link. We have to break this link. It should not point to node number 3, but we have to make it to point to. This is at the moment this is pointing to node number 3. But what's our job? How can we insert this node here? That means we have to make this node point to this node, and we have to make this back pointer of node number this new node. This back pointer of new node points to null, but we'll have to make it to point to this node. Okay. Likewise, the backward pointer of node number 3 points back to node number 2, but we will have to make it to point to this newly created node, so that we have to set this link right. Okay, and the forward pointer of this newly created node, it points to null, but we will have to make it to point to back to this. So we will have to set 4 pointers right. Only then we will be able to induct this new node at this given position. So now there is a problem. Once if we set this link is this forward pointer of node number 2 points to, it contains the address of node number 3. Once we will set this to point to this new node, we will lose this, we will lose the address of this node number 3. That's what we would not want. So that means if we set these pointers right at this moment, we will lose track of this node number 3. We will not be able to get this node once we set these links point to this node. So we will have to develop a mechanism to preserve the address of this node. That means we will need another pointer which we would use to preserve the address of this node before setting these links right. So we will have to have another pointer. So here after this statement we will say struct dbll star, let us call that pointer as preserve and set it to null at the first place. Okay, now what is the purpose of this preserve? It has to preserve the address of this node before setting these pointers or relinking these pointers. So how can we get the address of this node and assign that address to this pointer? Obviously we will be able to get the address of this node with traverse pointer. Traverse fptr contains the address of this node, so we will have to say preserve equal to traverse fptr. Now with the help of this statement, what we have done is we have assigned the address of this earlier node number 3 to this preserve pointer. Now preserve points to this node number 3, earlier node number 3. That means I'll draw these two pointers, node number 2 and node number 3, separately here so that it becomes very clear to you. So this was our node number 2. It was pointing to node 1. This is the back pointer. Okay, and this is pointing to node number 3, right, and back pointer of node number 3 is pointing back to node number 2. So this is node number 2, this is node number 3, and this is pointing to null, right? So this is the back pointer and this is the forward pointer of node number 2. So we will do one thing. See, we had this traverse pointer point to this, and by this statement what we achieve is we get another pointer, namely preserve, and this points to this pointer, so this node. So now the address of this node is now safe, it is preserved with this preserve pointer. Now we are free to relink these pointers, restructure the links, right? So after this statement we have to make, suppose this is the new node. Okay, so this at the moment is null and this is null. Its address is contained in PTR. Okay, its address is contained in PTR. Now we will have to break this link. Instead we will have to point this link to this node. Okay, and this back pointer of this node is pointing to null. We will have to make it not point to null but point back to this. Likewise we will have to make this link not point to null but point to this, and this back pointer of node number 3 not point back to node number 2 but point back to this node. So we will have to set these 4 links right. So we will say traverse FPTR arrow operator FPTR equal to, it was pointing to node number 3 but we have to make it to point to this new node, and its address is contained in this PTR. So we will say PTR. Now this link is done, and now we will have to make this back pointer of this node point back to node number 2, with the address of which is contained in traverse. So we will say PTR BPTR equal to traverse. Now these two links are set right. Now two links remain. So we will say PTR FPTR equal to, this was PTR FPTR was pointing to null but we have to set it to point to this node number 3, the address of which is contained in preserve. So we will say preserve. Okay, now this link has been set. Now the back pointer of this node number 3, it was pointing to node number 2 but we will have to make it to point to this new node, the address of which is contained in PTR. So we will say preserve BPTR. That means BPTR of preserve equal to PTR. Okay, so we have set these 1, 2, 3 and 4. We have set these. So with the help of these 4 lines of code, we have inserted this new node at our region of interest. So we have achieved what we had to. Then you can always set these traverse and preserve pointers to null, because at the moment they are pointing to their respective nodes, but we can set them to null so that they further point to no node. And then we have our head pointer safe with us, so we can traverse the entire list. That means the list including the new node with the help of this head pointer. So I hope this is clear to you. So after these statements, what actually we have achieved is this. Now this is like this. This is the head pointer. Okay, this points to node number 1 that was containing 5. It was null, and it will point to node number 2. It was containing 10. it was pointing back to node number 1, and now this will point to the new node, that is this. It will point back to 2, and this will point to 4th node. It will point back to this, and it will point to null. So this is node number 1, this is node number 2, this is node number 3. So this is the new node we have inserted, and this is node number 4, and with this head pointer we can traverse this entire list, right? So I hope this becomes very clear to you, as this is very easier to understand if you keep your focus to these statements and if you are attentive. Thank you very much. I hope this must be now very clear to you, and you must not face any problems whatsoever in inserting a new node at some intermediate position. Let us suppose we had to insert it at after position number 2, that means after second node. Let's suppose you are given a problem to insert a new node after position number 3, after position number 4, at position n. So you will set your index accordingly, right? So there should be no problems with this. Go through this once again. If at all you face any problems, do call me. I am just a call away, or catch me on my WhatsApp. I am always available to answer your queries. Thank you very much.